It's just a short video on the effects of power consumption with respect to frequency of choke ballasted high intensity discharge fixtures. Specifically this little bugger right here, which is a 70 watt metal halide. It takes those double-ended lamps, which you can't really see because of the glare. However, this is a fixture that I got from England for virtually nothing, which is why I have it. Of course, fairly cheap fixtures, you can see from that crack, because the ballast came loose in shipping and put a little bit of a ding in the case, and because very cheap fixture, I would not be surprised if the housing of this thing was pot metal, because it certainly tore like cheap pot metal. So yeah, this guy is going to be a work light. It is not going to live outside because corrosion. But yeah, again, 70 watt fixture. However, look at this power meter, 61.9 watts. And in previous burn testing I was doing with this thing, burning in the sense of the lamp operating, it peaked at about 63 and change watts. So yeah, the lamp is being underdriven. I estimate on probably about 52, 53 watts or thereabouts. So it's running at about 75% of rated power. Because there are going to be, you know, however many watts dissipated in the ballast. And so the next stage of this test is running the thing on 50 cycles per second. And fortunately I've got a couple of 50 cycle per second inverters. And that is what I am doing down here, is I am charging up some 12 volt batteries to run that inverter on, because the inverter is 24 volts. And now I've got my 50 cycle inverter, or one of the two that I've got, hooked up to those batteries. There it is, 222 volts. Using 222.2 volts at 50 cycles per second. Now, cycle through, low, high, that, and okay, let's now knock on wood the inverter will start this thing. And it did. Good. There's a lot more pronounced flicker this time because this is running on 50 cycles per second now. So, flooding mosquitoes in multiple senses of the word. So I'll come back when this is warmed up. Well, we'll cut to the next clip, but it's going to take a couple of minutes. Here's the fixture at more or less steady state. It's bouncing around 66.9 to 67.2 watts, so it's using about 67 watts. And this is quite interesting, because ordinarily I'd expect this thing to draw about 75 to 80 watts, factoring in ballast losses. And I think that because cheap crappy fixture, this is using a cheap crappy ballast that has an excessively high inductance. As you can see, the flickering there, because again, this camera 60 cycle frame rate, and this fixture is running on 50 cycles per second. And this light is also attracting a bunch of extremely stupid bugs. It's a yellow jacket. Almost, it's one of those Wasmanian mimic bugs. I really didn't think those things were out this late, but bugs are weird. Anyways, so yeah, some interesting results of this test. And what I'm probably going to do with this fixture is put in a frequency agnostic electronic ballast, which, yeah, ordinarily I don't really like electronic ballast for reliability reasons, but this is a fairly thin fixture. And yeah, regular American pulse start halide ballast, which, yes, this lamp is compatible with, wouldn't fit. And that means that I need an external ballast box, because, again, this is going to be a work light. Convenience is kind of important. Plus, again, those electronic ballasts don't care if they're running on 50 or 60 cycles per second. So that snapping noise in the background is one of my bug zappers, because there are a lot of bugs out right now, because I'm filming this at 4:34 a.m. because I'm weird. And power has gone up very, very slightly. This is the output of the inverter. Now the output of the inverter's gone down. 9 milliamperes, 0.98 power factor. Those are just low and high. This is the minimum and maximum powers this thing is measured since it was last reset. It's for setting cost per kilowatt hour. And for these power meters, this elapsed time, that is the amount of time that the load has been on. That isn't the amount of time that this thing has been plugged in. Which is very useful if you're measuring appliances like refrigerators, what have you, which aren't on all of the time. And also, yes, this thing is dual frequency, 50-60 cycle per second rated. Lots of mosquitoes. And after running for well over an hour, we're up to a whopping about 70 watts. Now, of course, it dropped to 69.7. Yeah. Really cheap fixture. And most likely going to be getting a new ballast. And I'll use the one that's in it for experimental purposes for other stuff. Yeah, there you can really see the frame rate difference.